Hello everyone, welcome to the lab on integrated circuit technology. Today we'll be studying oxidation process in IC fabrication with the help of virtual lab at nanohub.org. In this experiment, we are going to observe the process of oxidation and dependence of oxide thickness on type of oxidation, that is whether dry or wet, temperature of the process and orientation of the silicon wafer.
So once you are on the nanohub.org page, click on resources and then select tools.
Once you have selected tools, you will be redirected to a new page. On this page, in the second column, select a TCAD lab.
Now click on launch tool.
You will be redirected to a TCAD lab window. If I zoom in, you can see a drop down menu here. Select the second option, Process Lab Oxidation. This is the window for Oxidation Process Lab. Here we have an option of selecting the type of oxidation, whether dry or wet, time required for growing this oxide layer, temperature at which the oxidation is to be carried out, and also decide the orientation of the wafer on which the oxide is to be grown. Adjacent to the Conditions tab, there is a tab for Model. In the tab, you will be able to select a mathematical model for oxidation process. We will be selecting Dean-Groos model. In the Coefficients tab, the constants and their activation energies are mentioned. Let's look into the problem statement. Here you will be given the initial thickness of the native oxide, the desired thickness of the oxide layer to be grown, and the temperature at which the oxidation process is to be carried out. You will have to calculate the time required for growing the desired thickness. These are the constants required for the calculations. Note down the formulas for calculating B by A, tau and T. Let's start with calculating tau and T for dry oxidation on a silicon wafer with orientation of 100. Now enter the given and calculated conditions and simulate to verify. Now if we zoom in, then we'll be able to observe that a thickness of 0.151 micrometers will be grown in 234.3 minutes. This satisfies the problem statement and the time calculated. Similarly, repeat the calculations for dry oxidation on a silicon wafer with 111 orientation and simulate and verify. Calculations for wet oxidation on a silicon wafer with orientation 100. Simulation and verification of the same. Wet oxidation calculation on a silicon wafer with orientation 111. Verification through simulation. Complete this table on the basis of your observation. Post lab questions. Thank you.